Hello friends, welcome again to this channel. This is where we find solutions for your needs. And today we have again this problem. Three-phase system problem. According to the problem, we are to calculate the line current for a Y connected load that has a 5 of 20 degree ohm impedance per phase, and this load is connected across a 120 volt three-phase source. So it means that the load is in Y connection. So this is the picture of that. Okay, so this is a Y connected system. Okay, so it can either be here, okay, and each one of these has an impedance of 5 of 20 degree ohms. This is also 5 of 20 degree ohm. This is 5 of 20 degree ohm. Okay, and this load, by the way, this load is connected to a three-phase source. So there is a three-phase source here. Okay, so I just make it like this one. This is my source. Okay, so this has a, let's say this terminal is 120 volts, also that one and this one. Okay, so when you connect that source and load, that will be the system. Now you are to solve for the line current. So what is the current here? The line current, IL. Okay, so you know that this is a Y connected load, and the current for the line current, and the phase current, the current that flows through this impedance, okay, these currents are the same. So IP is equals to IL here. Okay, so and what makes it different is the voltage. But since we are looking for the current, and the voltage supplied and the impedance are given, so we are to solve for that. Okay, so here also you know that the line voltage is not the same here as the phase voltages. Okay, so actually phase voltages here is you take the square root of 3 of times the phase voltage. That will be your line voltage. So we are to calculate now the line current. So what we will do is that we will apply Ohm's law. So we know that B by Ohm's law, the voltage is equal to the current times the impedance. And in this case, we are to solve for the phase voltage at this given impedance 5 of 20 degree ohm. So we know that in this case, in the Y connected, we know it that the line current is equals to, again, the square root of 3 times the B phase current, voltage, I mean. The line voltage equals to the square root of 3 phase voltage. But since the line voltage is given, we can now compute for BP. So B phase voltage is BL, which is 120 divided by square root of 3. That will be your phase voltage. Okay. So to be able for us to calculate for the line current, since phase current is equals to line current, and we are using again this concept from Ohm's law. So we have here I is equals to the voltage over the impedance. But since we are already given, or we have computed already the B phase. The B phase is 120 over square root of 3. And this one, Z is given, which is 5 cis of 20 degree. So for further calculation, so you have here your calculator. Okay, so here, and your calculator will give us for 120 divided by square root of 3, that is 69.28 over 5 cis of 20 degree. 69.28 divided by 5 equals 13.856 or 86. We will change the location of this angle from denominator to numerator. That will give us negative 20 degree. Okay, so this will be your current, the line current. Okay, 13.86 ampere. Okay, so again, we already solved for the line current. Thank you so much for watching this video.